Okay, so this worksheet has 8 questions, all the story problem variety. What we're going to do for each question is we're going to define what we want our variable to be. We have to come up with a letter for it, what does it actually stand for, and we're going to build the equation and solve that equation. By the time you're done with this worksheet, I hope that you understand story problems with equations a lot easier, in case you might see one on your test when you come back from fall break. So let's start with number 1. 331 students went on a field trip. 6 buses were filled and 7 students traveled in cars. How many students were in each bus? So the buses were filled. There were 6 of them, and there were 7 additional students, altogether 331 students on the field trip. We're supposed to find, it says, how many students were on each bus. What letter should we use for our variable?
B.
Isaiah? S for students. Okay. You could use B, that's fine. And you could use whatever letter you want to. I like using letters that represent what I'm trying to find. But it is students on a bus, so I understand why you're saying that. So Isaiah said S. S is going to equal, and I'm going to abbreviate here, number. That used to be called the pound sign. You probably recognize it as the hashtag now, but that stands for a number, like number 1, right? We've seen that before. So number of students. Specifically, though, because I know there's 7 students that drove cars and 331 that went total field trip. Number of students on each bus. That way I'm specific. And now I'm going to write the equation. So if you aren't writing small, it's probably a good time for me to tell you to go ahead and write small. So you can fit it here in between each problem. All right. So there were 6 buses that went. We don't know how many students were on each bus. That's what S stands for, but I know there were 6 buses. So 6 times S. 6 times however many students can fit on a bus. That's 6 full bus loads of students. Did students only travel by bus? No, there were some that traveled by car. How many? 7. So 7 more, and that expression represents all the people that went on the field trip. And how many people went on the field trip? 331. So that's equal to 331. That's our equation. 6 busloads of students plus 7 more equals 331. What number do we want to get rid of first? Isaiah. All right, so minus 7 on both sides. Isaiah, what's 331 minus 7? 324. And by the way, if you were solving this problem without writing an equation, that's still the first thing you would do. You'd figure out how many students were on the buses. If you take away the 7 that traveled by car, that means 324 total kids traveled by bus. And there were 6 buses, so that 324 were split evenly among the 6 buses. What's the next step then? What's the opposite of multiplying by 6? Gavin? Dividing by 6. Let's see what you get when you split it 6 equal ways. I don't know my 6 is that high, so we're going to go off to the side. You know them that high? Or you just had time to do the problem? 6 goes into 32. How many times? Anybody? How many times into 32? Shout it out. 5 times. That's 30. The difference of 2. Drop down your 4. 6 goes into 24 4 times, and it goes in perfectly. So that means 54. What? Students. 54 students rode each bus. That's why if we look up here, we actually know what S stands for. S is the number of students. And that's why if I was doing this one, I would prefer the letter S even over the letter B, because if I see B, it's going to make me think it's 54 buses, but that's not true. So 6 buses, right? So 54 students. But you could technically use whatever letter you want. So number 2. We're 1/8 the way through this worksheet, or 12.5% done. Aaliyah had $24 to spend on 7 pencils. After buying them, she has $10. Those are expensive pencils, too expensive. How much should each pencil cost? Okay, so what are we trying to find? Kara? How much they cost? Yeah, so what letter should we use, Kara? P. Yeah, so P for pencil, but P doesn't stand for the number of pencils. We already know she bought 7. P stands for the cost of a pencil. So this is going to be a dollar amount, is how I'll label my answer. All right, let's go chronologically through this. You know what chronologically means?
In order.
Like past to present, right? Yeah, in order of time. So she has how much money to start with? 4. Okay. What happens to the amount as she starts buying pencils? It lowers. It lowers by 7. But she didn't buy 1 pencil. She bought 7. Sorry. It lowers by 7 pencils. But not just 7 once, it's 7 pencils. We don't know what the cost is. So 7 times the cost of a pencil. She bought 7 pencils, each one cost P dollars. So whatever 7 times P, that's how much money she spent on pencils. 24 minus 7P. After she's done buying pencils, how much money does she have? 10. So this is all equal to 10. What number do I want to get rid of first, Austin? You are correct. And how do I get rid of that positive 24? That's right. Yep. Put a negative 24 on both sides, or subtract 24, however you want to say it. That will cancel out. Now, be careful here. This is going to leave you with negative 7P, not just 7P. There's still a minus in front of the 7, so it's negative 7P. All right. And then J, that negative 24, beneath the 10, are they going to go to war or join forces? They are going to go to war. Who wins the army? Who wins that battle? Negative army, thank you. And then how much do they win it by? That's right. Now you might be thinking, how can a pencil cost a negative number of dollars? It can't. But what happens when you divide a negative by a negative? Positive, and that's what our next step is. We're not dividing by 7. We're going to divide by the same number we were multiplying by. So we have to go back in time even further. We have to divide both sides by negative 7. And P is going to equal 2. 2 pencils? $2. That's why we like to just define what it is we're finding. It's not the number of pencils, it's the price of a pencil. Luke. Okay, your choice. Number 3. The sum of 3 consecutive numbers is 72. Oh, we got it. I didn't quite lead him or let him move too far on that one. The sum of 3 consecutive numbers is 72. What are the smallest of these numbers? What does consecutive mean? Isaiah? Back to back to back. It's a good way of describing it, right? If I said the Colts were going to go out and get consecutive wins of the next 2 weeks, that would mean in a row. I doubt they do this year, right? So in a row, right? Consecutive numbers are ones that are back to back to back. So for example, 6, 7, and 8 would be consecutive numbers. 20, 21, and 22. So we're just finding a number here. So we could use whatever letter we want to, but I mean, there's not gonna be a label for this. It's not dollars, it's not pencils. It's just a number. So we could use N for number or X or whatever you want to, whatever your fancy is. I'll just use N for this one. So N is going to equal the smallest number. And there it is. N. Now, the next number after N, let's assume for just simplicity's sake, that N is 10. What's the next number after 10? 11. So it'd be N plus 1 more. See how that works? The next consecutive number, 10, 11, and 12, would be the first number plus how many more? Plus 2 more. So if N is 10, you have 10, 11, and 12, right? Okay. So those are our 3 consecutive numbers. What does sum mean? Sum means, Hugo? We're adding them. Yeah, so when you add them together, we're supposed to get a sum of 72. Now, you could do this problem without an equation, and it would involve a lot of guessing and checking. 3 consecutive numbers adding to 72. But the equation takes out the guess and check method. I just solve it and I have my answer. There's a lot of n's in this problem. Let's combine them, combining our like terms. So it's 1n, 1n, and 1n, maybe. Anybody? 3n. So when you combine your n's, you end up getting 3n. Now let's combine our constant terms. What's positive 1 and positive 2 give you? Positive 3. So that whole expression on the left side of the equal sign just simplifies to 3n plus 3 equals 72. Okay. What number do I want to get rid of now, Jade? The positive 3. Yeah, not the 3 in front of the n, but she said the positive 3, the one that's purple there, our constant term. All right, so we're going to subtract 3 from both sides. That's going to give us 3n equals 69. And then now we have to get rid of the 3 that's in front of the n. Logan, what's that 3 in front of the n doing to the n? And the opposite of multiplying? Dividing. Thank you. So we're going to divide by 3, divide by 3. And I bet you could go off to the side to do that, but we don't need to. How many times does n go into 6? Twice, perfectly. How many times does it go into 9? Thrice, perfectly. I don't think thrice is a word, but I like saying it. So n equals 23. The smallest of our numbers is 23, which means if you want to check your answer, 23 plus 24 plus 25 should add up to 72 if we wanted to find out those other, which we already have our answer because it was the smallest of those numbers. Yeah. All right, number 4 is a very similar question. This time it says the sum of 3 consecutive even numbers. Now your even numbers are 2, 4, 6, 8, 10, 12, 14, 16, right? All the numbers that 2 would go into. How far apart are the even numbers on the number line? Well, not. They're 2 apart. Every other, right? Like you'll be sitting in the auditorium. Right, Hugo, does that make sense? Yeah. So every other number. It's not 2, 3, 4, it's 2, 4, 6, right? Maybe we'll do an extra step. So 3 consecutive even numbers. We used n last time. Let's just use x, just because we want to be different. Let's let x equal the smallest of the numbers. So x is in my equation. There's the first number. Let's pretend, again, for simplicity's sake, that x was 10. It's probably not. It wasn't last time, but let's just say it was 10. What would the next even number be? 12. So it would be x plus 2. Yeah. So if x is 10, then 12 would be x plus 2. What would the next even number be? 10, 12, 14. So it'd be 2 more, but not x plus 2 again. It's this x 10 plus 4. Yeah, x plus 4. They're every other. Not times. Plus 4. There we go. So if x was 10, this would say 10, 12, and 14. Would you agree that these are even numbers? Okay, now I don't think x is 10. We're going to find out what it is. It does say the sum again, so we're going to add them together. And this time the sum is equal to 48. We're going to combine our like terms. We have, yet again, 1x, 1x, and 1x, making how many x's? 3x. Our constants, we have positive 2 and positive 4, making positive 6. So all that just simplifies to 3x plus 6 equals 48. Tyler, which number do I get rid of now? 6. You're right. And Tyler, when you minus 6 from each side, or I haven't used yet, what's 48 left here? Minus 6. 42. So that's going to give us 3x equals 42. And our last step, Chase, is to get rid of the 3. How do I get rid of that 3 in front of the x? Divide. You're right. We're going to divide both sides by 3. And if you don't know how many times that goes into 42, you could long divide. What is it, Cadence? 14. For those of you that haven't been working ahead, we can long divide. It goes in 1 time to 4, and it goes in 4 times to 12 evenly. So you are correct, Cadence. It is 14. So our 3 even numbers, not that we need to know all 3 of them, but we might as well since we've done all this work, are 14, 16, and 18. If you want to check your answer, you would see a 14, 16, and 18 add up to 48, and they do. We are now 4/8 the way through this, or 1/2, or 50%. Isabel. How do I know that 14, 16, and 18 worked, or how did I come up with x plus 2, and x plus 4? Okay, so I had to come up with the first number, right? So we don't know what the first number is. We use any variable for that one. Because it said they were consecutive even numbers. Consecutive means in a row. And even numbers are 2 apart. I know that if the first number is x, the next number is 2 more than that, x plus 2. Now, the third consecutive number was 2 more than that one. But since I'm using x, I got to go back to the x. It's going to be 4 more than the one I started at. Okay, so that's how I came up with this one. The last one, they were just consecutive. This might be a little bit easier to understand. They were just consecutive regular numbers. So if this is the first one in, the second one's going to be 1 more than that. And the third one's going to be 2 more than that. And the next will be 3 more than that. And then 4 more than that. See how that works? But we weren't doing 4 or 5 consecutive numbers. We're just doing 3 consecutive numbers. It's a good question. Number 5, you bought a magazine for $5 and 4 erasers, and you spent a total of $25. And I thought the pencils were expensive. How much did each eraser cost? What letter should we use for our variable, Austin? E. I like it. And Austin, what does E stand for? That's right. Yeah, not the number of erasers, but the cost of each of them. We already know that you bought 4. So that's not what we're trying to find. We're trying to find what the cost of each of them was. So let's build this equation chronologically. Caitlin, what was the first thing you bought? And how much did that cost? All right, so immediately you got $5 down. Then you purchased 4 of those erasers. Now, if the cost of an eraser is E, then the cost of 4 erasers would be 4E. That expression represents the amount of money that you spent. We know what that expression is equal to because it says you spent 25. So 5 plus 4E equals 25. All right, Logan, what number do we want to get rid of first?
Positive 5.
Yes, how do I do it?
Solve it to -5.
All right. And then Logan, what is 25 minus 5? 4E equals 20. Okay, so that makes sense. If you're trying to find the cost of an eraser and you spent $5 in the magazine, then take that $5 away from the 25 you spent, and that means you spent $20 on 4 erasers. Divide by 4, and you'll know the cost of each. What is 20 divided by 4? Anybody? Yeah, each eraser was $5 dollars. Yeah. Every story problem has to have a label. The only ones that haven't had a label so far have been number 3 and number 4. That's because we were finding numbers and not actual amounts of anything. Yeah. That better be the type of eraser that erases it in one stroke. Doesn't leave any of the pink smudges or crumbs behind as you're going through. I don't know if an eraser like that exists, but
It has to be good.
see, I don't know. I mean, you guys, I don't buy erasers because I don't make mistakes. So I mean, you guys will be the experts in this, right? You buy erasers all the time.
You will.
What's that?
My research.
I mean, don't you need erasers for it?
What's the what on my board? Oh, that's because after I do all my problems correctly, I have to erase them for the next class.
Yeah.
Because sometimes students come up to my desk and I tell them they did the problem wrong. I say, here, take this eraser that I never use, and you can borrow it. Because sometimes My stylus doesn't pick it up correctly.
Yes.
Like, sometimes my stylus writes a 3 when I need to write a 4. You know what I mean? Like, come on, I just need to get a new stylus. All right, you can keep pointing out all the mistakes you want, but it's hurting my feelings, so please stop. I'm going to L trick you here. Marie, that was bad. I can't talk and read and write. Definitely can't do those things at the same time. So, number 6. Number 6, we are now 62.5% of the way down. Maria bought 7 boxes. A week later, half of all her boxes were destroyed in a fire. There are now only 22 boxes left. She must have had a lot. With how many boxes did she start? What are we trying to find? Okay, so let's use B. Okay, but specifically, B is the number of boxes she starts with. Because I already know how many she ends with. It's in the problem. No, I mean, no, I know how many she has. It's in the problem.
That way.
She has 22 right now. So I want to be specific. When I say boxes, I mean the boxes she began with, right? So let's build this problem chronologically. She starts with B boxes. I have no idea how many that is. But she feels the need for more of them. So she immediately goes out and does what?
Say 8 boxes.
What'd she do, Luke? What'd she do, Mason? Read the problem. What did she do?
I just said.
Mason, read the problem. Read the first sentence to me, please.
She bought some boxes.
Thank you. She bought 7 boxes. So she had some, she buys more. She felt the need for more of them. Okay, she buys 7 more. A week later, it says half of all her boxes were destroyed in a fire. Now, not half of the boxes she started with, half of them that she has right now. So all the boxes, right? And of course, taking half means to divide by what? 2. So she had some boxes, she buys 7 more, and half of those were enough. Now she has how many? 22. And this is a big fat fraction. And just like we did on our worksheet from yesterday to solve a big fat fraction, identify what the denominator of your fraction is. 2. Multiply both sides by 2. Okay, don't multiply the 2 to the 7 or to the b, it's going to cancel out. So that leaves me at b plus 7. And I do need to multiply 22 times 2. 44. That's right. So here's what we just found out. If we go back in time, if we retrace our steps, right? The last thing that happened to her was that fire. So let's go back in time before the fire. If she wouldn't have lost half of her boxes, she'd have 44 right now. Right? Let's go back in time even further. Mason said she bought 7 boxes on top of what she already had. Let's go back in time before she bought those boxes. Subtract 7. Subtract 7. How many did she have before she bought those 7 boxes? 80?
37.
37. 37 what, 80? 37 what, 80? Boxes. Thank you. Is it?
Yeah.
Okay. Well, try that on your quiz and see if you move half a point around.
I will.
All right, did everyone understand that? It was boxes that she had plus 7 more, all got burned up in the fire, right? She lost half all those, divide by 2. And so we invert those. We invert those steps, we times by 2, and then we take away the 7 that she bought. She started with 37. Number 7, we're now 75% of the way down the worksheet. Suma Lee won 40 super bouncy balls playing horseshoes at her school's game night. Later, she gave 2 to each of her friends. She only has 8 remaining, 8 bouncy balls remaining, not 8 friends. They didn't pass away. How many friends does she have? So what are we trying to find? Friends. Yeah, not bouncy balls. Read the last sentence again. F is the number of friends. Okay, sit up in your desk. F is the number of friends. So let's build this equation chronologically. She starts with 40 super bounce balls. She wanted a school carnival. Sounds fun. Okay, it says she gave two to each of her friends, so she starts giving them away. What happens to her bouncy balls?
They go down.
Yeah, they're going down. And she gives 2 away to each friend. So 2 times the number of friends she has. That leaves her with how many? 8 super bounce balls. Let's solve this equation by first getting rid of what number? 40. It's a positive 40, so I need to put a negative 40 underneath. That's not what it says. Oh. Negative 2F. Means you're giving 2 bounce balls away for each friend. Equals, and then 8 and negative 40 are going to go to war. The negatives win by how many? That's right, negative 32. Now you can't have a negative number of friends. Even the most lonely person can't have a negative number of friends. So we're going to divide by negative 2. We're going to divide by negative 2. You guys staying after class to finish this? Didn't think so. What's a negative divided by a negative? Positive, and 32 divided by 2 is? Tyler? 16. And what's F stand for? 16 friends. It's a good number. It's a healthy amount. Not everybody's going to be your friend. Not every acquaintance or every classmate is a friend. We're now 87.5% of the way done. About to be 100% if we can finish number 8. Number 8 says Amani spent half of her weekly allowance playing mini golf. To earn more money, her parents let her wash their car for $4. Cheapskates. What's her weekly allowance if she ended with 12? What's her what? Weekly allowance? I like A. Now, what is an allowance? It's money. So A is going to equal the dollars of allowance. That way we know when we label this, it needs to be dollars. Now, she starts off with her allowance. I don't know how much that is, so we'll just put A. She starts off with A. Here we go, there's A. She immediately spends half of it. So what are we dividing by? 2. Then, after she spends half, she earns $4 more by washing her parents' car. Now, how much money does she have? $12. Now, is this a big fat fraction?
Yes.
No. Last time something happened and then she got everything divided by 2, the fire. This time she immediately gets half her allowance and then adds 4 more. So we can get rid of the 4. If we go back in time chronologically, how much money did she have before her parents gave her $4 more? 8. Let's go back in time even further. Before she played mini golf and spent half of her money, how much money did she have? $16. That must be her allowance. So you know what? I take back. Her parents aren't cheapskates. $16 a week for allowance. I know a lot of you don't get paid anything for a chore. All right, on your way out, please make sure right now your name is on your worksheet. Don't turn in a worksheet without a name or I throw it away. You better watch the video. All right, friends, it's ready, and bye-bye. See you guys back here for SLT.
I don't like